So hello friends, in this video let's see the construction of Kohonen self-organizing mapping. So here is our question and we are given with four input vectors and learning rate and weight matrix, two vectors in it. So the first step what we need to find in this is we have to find the Euclidean distance for each of the given four inputs with respect to the weight vectors. So let the distance from first vector be d1 and d2 will be the distance to the second weight vector. So now let's proceed to the problem. So now let's take the first input vector 0, 0, 1, 1. So how we need to find d1 means the Euclidean distance for this input vector to the weight vector 1. So we need to subtract this input vector from this weight vector and we have to square it. So that will become 0.2 minus 0 whole square plus and 0.4, the corresponding value is 0. So 0.4 minus 0 whole square and 0.6 minus 1 whole square and 0.8 minus 1 whole square. So if you simplify this 0.2 minus 0, you will be getting 0.2 and its square will be 0.04 plus 0.4 minus 0, 0.4 and 0.4 square 0.16 and 0.6 minus 1 you will be getting minus 0.4 and minus 0.4 when we square it you will be getting plus 0.16 and here 0.8 minus 1 minus 0.2 if we square minus 0.2 we will be getting plus 0.04 and if we sum this 0.08 plus 0.32 so 0.4. This is D1. Now for the first vector, for the first input vector, let's find D2. So now you have to consider this. So 0.9 minus 0 square plus 0.7 minus 0 square plus 0.5 minus 1 square and 0.3 minus 1 square. So 0.9 minus 0 is 0.9 and its square is 0.81. Coming to this 0.7 minus 0, 0.7, its square is 0.49 and 0.5 minus 1, it's minus 0.5. When we square minus 0.5, you will be getting 0.25 and 0.3 minus 1, it's minus 0.7 and if we square minus 0.7, we will get 0.49. So now if we add these, we will get 0.49, 0.49, 0.98 and so around 2.04. So now for the first input vector, it's done calculating the D1 and D2 and what we need to do now is we have to compare this D1 and D2 and see which is minimum. So 0.4 is less than 2.0.4. That means D1 is less than D2. Since D1 is minimum, the vector which is minimum is considered as winning. So now we need to write a conclusion that D1 is winning. The next step is the vector which is winning, that corresponding weight vector should get updated. So since D1 is winning, we need to update the first vector in the weight matrix. So how we need to update the weight matrix is, so our new weight So our new weight will be world weight plus and learning rate alpha into and our world our vector x minus our world weight. So this is a formula which we need to use for updating the weights. So now let's update the 0.2. So the new weight for 0.2 is world weight 0.2 plus our learning rate alpha 0.5 and we will be taking x1. So 0 minus and again the world weight 0.2. This will give you 0.2 minus 0.1, so 0.1. So now let's update 0.4. Old weight is 0.4 plus our learning rate alpha of 0.5 and our x2. So 0 minus world weight 0.4. So this becomes 0.4 minus 0.2. So 0.2. And now let's update 0.6. Old weight is 0.6 plus our learning rate alpha 0.5 into, now we have to take x3, that is 1 minus our world weight 0.6. So now we will get 0.6 plus 0.5 and 0.4, 0.2. So this gives us 0.8. Now let's update 0.8, the final one. 0.8 plus our learning rate alpha 0.5 and now here we have to take x4 here. So our x4 is 1. So 1 minus 0.8, that is 0.8 plus 0.1, 0.9. So our new weight is 0.1, 0.2, 0.8 and 0.1 and the rest will remain same, 0.9, 0.7, 0.5 and 0.3. Now using this updated weight matrix, let's do the same process for the second input vector. So our second input vector is 1 triple 0. So 1 triple 0 and our new weight is 0.1, 0.2, 0.8, 0.9. So 0.1, 0.2, 0.8, 0.9 and 0.9, 0.7, 0.5, 0.3 and our alpha is 0.5. So now let's find D1. So D1 is 0.1 minus 1 square. 0.1 minus 1 square plus 0.2 minus 0 square and 0.8 minus 0 square and 0.9 minus 0 square. So this gives us 0.1 minus 1 minus 0.9. So if we square it, 0.81 plus 0.04 plus 0.64 plus 0.81. Sorry, it's 81. So if we add this, we will get 2.3. Now let's find D2. So 0.9 minus 1 square plus 0.7 minus 0 plus 0.5 minus 0 and 0.3 minus 0 square. So 0.9 minus 1 is 0.1. So 0.1 into 0.1 is 0.01. And 0.7 square 0.49 and 0.5 square 0.25 and 0.3 square 0.09. So this gives us 0.1, so 0.84. See now, D1 is 2.3 and D2 is 0.84, which means D1 is greater than D2. So since D2 is minimum, now D2 is winning. D2 is winning. So it's time to update our second method in the weight. So now let's update 0.9. So our old weight 0.9 plus alpha 0.5 into our x1 is 1 minus our old weight 0.9. So 0.9 plus 1 minus 0.9, 0.1, 0.1 into 0.5, 0.05. This gives 0.95. And now let's update 0.7. Old weight 0.7 plus alpha 0.5 into x2 is 0, 0 minus our old weight 0.7. So this gives 0.7 and 0.5 into minus 0.7 is minus 0.35. So this gives 0.35. Since 0.35 twice is 0.7. And let's update 0.5. So 0.5 plus our alpha 0.5 into our third is 0 minus and old weight 0.5. So 0.5, this gives minus 0.25 and here we will get 0.25. And now let's update the final one 0.3 plus our learning rate 0.5 into our x4 is 0 minus our old weight 0.3. So 0.3 minus 0.15, this gives 0.15. So here comes our new updated weight. So our new updated weight is first letter remains same 0.1, 0.2, 0.8 and 0.9. And now let's update the weight with our new values. So 0.95, 0.35, 0.25, 0.15. So now using this weight matrix, let's perform D1 and D2 and see which is minimum and update the corresponding weight matrix in the of the vector. So now let's go to third input. Our third input is 0.110. So now we are performing for third input 0.110 and our updated weight matrix is 0.1, 0.2, 0.8, 0.9 and here 0.95, 0.35, 0.25, 0.15. 95, sorry, 35, 25 and 15. And learning rate is 0.5. Yeah, let's perform D1 and D2 and see which is minimum. So D1 is our weight 0.1, minus 0 square plus 0.2 minus 1 square plus 0.8 minus 1 square and 0.9 minus 0 square. This uses is 0.01 and 0.2 minus 1 0.8 and x square 0.64, 0.8 minus 1 0.2 square, that is 0.04 and 0.9 square 0.81. So this gives 5 and 1.5. So it's fine. And D2, so 0.95 minus 0 square and 0.35 minus 1 square and 0.25 minus 1 square. Hope you understand how I am performing this Euclidean distance thing. Okay, so 0.15 minus 0 square, so 0.95 square. So if you consider the last 3 digits, you will be getting 0.902 and 0.35 minus 1. So 0.35 minus 1, 0.422 and 0.25 minus 1 square is 0.562 and 0.15 square is so 0.15, 0.022. So if you sum this, you will get 1.908. So if we compare 1.5 and 1.9, you see 1.5 is lesser than the 1.9. So 1.5 is minimum, 1.5 is D1, so D1 is winning. If D1 is winning, we need to update this. So let's update 0.1. So all weight is 0.1 plus our loading that alpha 0.5 into what? X1. So our X1 is 0. 0 minus our whole weight, 0.1. So now 0.1 and minus 0.05. So this gives 0.05. Now let's update 0.2. All weight is 0.2 and our learning at alpha 0.5 into our X2 is 1. 1 minus our world weight 0.2. So this gives 0.2 and 0.5 into 0.8 0.4 plus 0.4. So 0.6. Now let's update 0.8. 0.8 plus our learning rate 0.5 and our X3 is 1 minus whole weight 0.8. So 0.8 plus 0.1, 0.9. And let's update the final one. Whole weight 0.9 plus alpha 0.5 into our X4 is 0. 0 minus our whole weight 0.9. So 0.9 minus 0.45. So this gives us 0.45. So here comes our new values for our weight matrix. So our updated weight matrix is 0.05, 0.6, 0.9, 0.45, and 0.95, 0.35, 0.25, 0.15. And now with this updated weight matrix, let's find the D1 and D2 and see which is minimum and perform the updation of weights. So with that, we will be completing the first iteration. So our fourth input is 0001, 0001, and our updated weight matrix is, let me see, it's 0.05, yeah, 0.056945, 0.05, 0.6, 0.9, 0.45, and 0.95, 0.35, 0.25, 0.15, and the alpha is 0.5. Yeah, it's fine, super. So now let's find the D1. D1, you know, right? We need to subtract the input value from the weight. So 0.05 minus 0 square plus 0.6 minus 0 square plus 0.9 minus 0 square and 0.45 minus 1 square. So this gives, yeah, 0.05 square, 0.0025. So yeah, I'll write below. 25 and 0.6, 0.36, 0.9, 0.81, and 0.45 minus 1 square, it is 0.722. Sorry, 0.3025. This means 1.475. Now let's find D2. So it is 0.95 minus 0 square plus 0.35 minus 0 square plus 0.25 minus 0 square plus 0.15 minus 1 square. So 0.95 square, as said, is 0.902, and 0.35 square is 0.122, and 0.25 square 0.0625, and 0.15 square is 0.722. So if we add this, we will be getting 1.81. So it's 1.4 and it's 1.8. So 1.4 is less than 1.8. So D1 is minimum. D1 is minimum. Yeah, so now update the weight. Update this factor weight. So now let's update the 0.05. Whole weight is 0.05 plus our alpha 0.5 into our x1 is 0, 0 minus our whole weight is 0.05. So this gives 0.05 into minus 0.05 minus 0.05. So yeah, 0.05 minus 0.025. This gives 0.025. So and 0.6, this one, plus alpha 0.5 into our x2 0 minus our whole weight 0.6. So yeah, 0.6 minus 0.3. plus 0.3 and let's subtract 0.9 plus 0.5 into x is 0 minus 0.9, that is 0.9 minus 0.45, you will get 0.45, and now let's subtract the final one, 0.45 plus our alpha 0.5 into our x4 is 1 minus our whole weight 0.45. So this gives us 0.45 plus 1 minus 0.45 is yeah 0.55. So if we add this, we will get 1. So our final updated weight for the first iteration is the value 0.025, 0.3, 0.45 and 1, and 0.95, 0.35, 0.25, 0.15. So it is done for the first iteration. If at all, if you ask it to perform the further iterations, so what you need to do is, so we will be using this weight matrix for the first input in the next iteration, and follows the weight updation, which is minimum considering that updating that particular vector. But the change is for every iteration you need to update the alpha. So the formula for updating the alpha after every iteration is we need to multiply our old alpha with the value 0.5. So if at all you are going to perform the second iteration, you have to take alpha as our new alpha will be 0.5 into our old alpha. So 0.5 into our old alpha is 0.5. So 0.5 into 0.5 will be getting 0.25. So this value you have to use for second iteration, and goes like that. More the iterations, you have to update your alpha value for each and every iteration, just making it inputs of the value. That's it. This is how the Kohonen and Fibonacci mapping is done. Thank you.